Assalamu alaikum. In this video, I'm going to talk about the distance between two parallel lines and the distance between a point and a line. Let's get started. When talking about the distance in this lesson, we can summarize the ideas into two main ideas. The first one, the distance between two parallel lines. And the distance between a point and a line. Well, the easiest way is to use two important formulas. If you are asked to find the distance between two parallel lines, for example, line y equals mx plus b1, and let's assume that the second line is y equals mx plus b2. It is very important to notice that these two lines have the same slope. So parallel lines have the same slopes. The y-intercept is different. So the y-intercepts are different, but for sure they have the same slope. So what formula I'm going to use here? I'll be using d equals the absolute value of the difference between the y-intercepts, so b2 minus b1. It is very important to use absolute value. Remember, this is a distance, and distance should be positive, divided by the square root of 1 plus m squared. M is the slope. What if I want to find the distance between a line and a point, a given point? Which formula can I use here? So in this case, we're going to use a different formula. The distance is the absolute value of a x0 plus b y0 plus c divided by the square root of a squared plus b squared, where x0 and y0 is the given point and the line is written in standard form. So the line should be written as ax plus by plus c equals 0. So it is very important to notice that if you want to use the first formula, the line should be written in a slope-intercept form. But for the second formula, the line should be written in standard form. So let's try to apply these two formulas. Let's have example. What if I ask you to find the distance between these parallel lines? Y equals minus 2x plus 5. Y equals minus 2x minus 5. So for sure these lines are parallel since they have the same slopes. So this is the first thing we can identify, the slope. The slope is minus 2. Because here we are finding the distance between two lines, I know that I'll be using the first formula, which is d equals the absolute value of b2 minus b1 divided by the square root of 1 plus m squared. So we need to know or identify b1 and b2. b1 is 5, the y-intercept in the first line, and b2 is the y-intercept in the second line, which is minus 5. Let's plug in these values in the formula. So the distance equals the absolute value of minus 5 minus 5 divided by the square root of 1 plus minus 2 squared. Let's evaluate and simplify. Minus 5 is minus 10. So here we have the absolute value of minus 10 divided by the square root of 1 plus minus 2 squared is 4. Be careful. Minus 2 squared is 4. It's not minus 4. It is 4. It is positive 4. So the absolute value of minus 10 is 10. So as you see, this is the purpose of having the absolute value, to take the minus sign away here because we are dealing with distance. Distance should be positive. Divided by the square root of 1 plus 4, which is 5. After simplifying, you will get to the square root of 5, which is approximately 4.47 units. And that's it. Let's have more example. What if we have 3x plus y equals 3. The other line is y plus 17 equals minus 3x. As you see here, each line is not written in slope-intercept form. Again, what is the slope-intercept form? The slope-intercept form is y equals mx plus b, where y is isolated. The slope-intercept form shows the slope and the y-intercept. So the first step here is to write each line in a slope-intercept form. So what I will be doing here is just moving 3 to the other side, and don't forget to change the sign. So you will get y equals minus 3x plus 3. So this is the same as subtracting 3x from both sides. For the other equation, we need to move plus 17 to the other side, or subtracting 17 from both sides. You will get y equals minus 3x minus 17. So as you see here, the slopes are the same, and that's because these two lines are parallel. Now let's identify P1 and P2. P1 equals 3 and B2 equals minus 17. Use the first formula, which is the absolute value of B2 minus B1 divided by the square root of 1 plus m squared. You will get minus 17 minus 3, the absolute value of minus 17 minus 3 divided by 1 plus minus 3 squared. Don't forget that the slope here is minus 3. So let's simplify. The absolute value of minus 20 divided by the square root of 1 plus minus 3 squared is 9. The absolute value of minus 20 is going to be 20 divided by the square root of 10. Use your calculator and simplify. You will get to the square root of 10, which is approximately 6.32. So keep in mind, to use this formula, each line should be written in a slope-intercept form. What if we want to find the distance between a line and a given point? For example, what if I ask you, find the distance between the line y equals 1 over 6x plus 6 and the point minus 6 and 5. So in this case, we need to use different formula. The formula that we're going to use is D equals the absolute value of ax0 plus by0 plus c divided by the square root of a squared plus b squared. So it is very important to keep in mind the line should be written in standard form. So as you see here, the line is not written in standard form. In standard form, all the terms should be in one side, the other term should be 0. So I'll be moving y to this side. You need to change its sign or subtract y from both sides. So you will get 1 over 6x minus y plus 6 equals 0. In standard form also, we need to have integer coefficients. So as you see here, the coefficient of x is 1 over 6, which is a fraction. So in order to change it to integer, I'm going to multiply both sides by 6, which is the denominator. So both sides should be multiplied by 6. You will get 1x, which is x, or you can write 1 if you wish. 6 times minus y is minus 6y. 6 times 6 is 36. 0 times 6 is 0. So that step is very important. The line should be written in standard form. Then let's identify the coefficients a, b, and c. A is going to be the number multiplied by x, which is 1. B is the number multiplied by y, which is minus 6. And c is the constant, which is 36. Now, let's plug in these values in the formula. You will get D equals the absolute value of A, which is 1, multiplied by x0. Now, what is x0 and y0? x0 and y0 are the x and y coordinates of the point of the given point in the question. So x0 equals minus 6 and y0 equals 5. So I'm going to write here 1 times minus 6 plus minus 6 multiplied by 5 and add the constant, which is 36, divided by the square root of a squared and b squared. That means 1 squared plus minus 6 squared. Let's simplify. If you simplify the denominator, you will get the absolute value of minus 6 multiplied by 5 is minus 30 plus 36 divided by the denominator. Let me write it properly. Can I erase this and write it here? So you will get minus 6 minus 30 minus 36 divided by the square root of 1 squared plus 36, because minus 6 squared is plus 36. The numerator is going to be 0 divided by the square root of 37. So the answer is 0. So that's surprising that the distance is 0 between this point and this line. What does that mean? What is the geometric explanation for this answer? Well, the distance here is 0 because that point lies on the line. When the point lies on the line, the distance between them is going to be 0. This is the end of the video. Hopefully you found it useful. Thank you for watching.